Mikro işlemciler dersinin ikinci haftası laboratuvar dersine hoş geldiniz. Abbas hocam bu dersi asiste ediyor, yardımcı olacak. Ben de burada olacağım. Gerekli yerlerde hocam müsaade ederse katılım da yapmaya çalışacağım. Katılımınız için size teşekkür ederim. Abbas hocam size de çok teşekkür ederim. Kaydı başlattım hocam.
Teşekkür ederiz hocam. Arkadaşlar merhaba. İlk hafta bahsettiğim gibi emülatör yönetlenişi, dersin nasıl işleneceği, help arayüzümüz, instruction setlerini neden göreceğimiz bunlardan bahsetmiştim. Size ayrıca bir de dersimizin bahsetmiştim. Küçük bir hatırlatma, şöyle arkadaşlarımın bilgisini de beklemiş olacağım. Küçük bir hatırlatma yapacağım. Ve biraz rahatladığımda İngilizceye dönüp dersi başlayacağım. Hatırlarsanız bütün duyurularımızı benim web sitem üzerinden Lab kısmından duyuruyorduk arkadaşlar. İşte hafta maillerimiz oluyor. İsterseniz siz girip öncesinde hangi kodu işleyeceğimiz, hangi instruction seti işleyeceğimizi okuyordunuz. Dersi hazırlamaya çalışıyordunuz. Emülatörümüz vardı. Emülatörümüzün help'i vardı. Bize en çok yardımcı olduğu kısım burasıydı arkadaşlar. Önce vasıtalarla geliyordu karşımıza. Instruction set kısmı 80-86.
Abbas hocam bir cızıltı var. Neden bilmiyorum. Size de geliyor mu?
Hocam sanırım sizin mikrofonun açık değil. İsterseniz siz kapatın aynen hocam. Ben devam edeyim. Teşekkür ederim hocam. Şöyle bir netleştireyim. Şu an cızırtı gelmiyor diye düşünüyorum. Bir chat'e bakıyorum. Benim sesim şu an net gelmiyor mu arkadaşlar? Daha iyi şu an. Tamam. O cızırtı Muharrem hocamızın mikrofonu açık olduğu için sanırım arkadaşlar. Tamam. Devam ediyorum o zaman. Bu sırada da arkadaşlarımız girdi sanırım. 26 kişi falan olduk. Anlaşıldı. Geçen hafta da 25-26 idik. Bu hafta da 25-26. Dönem böyle gidecek anlaşıldı. Bu 25-26 arkadaşlar büyük ihtimalle sorunsuz bir şekilde dersi geçecek arkadaşlar anlaşıldı. Şeye döneyim. 80-86 instruction set'e işte haftanın komutuna giriyorduk. İlk sütun komutumuz, ikinci sütunumuz komutun aldığı parametreler, üçüncü sütunda açıklamalar var demiştik. İşte bu şekilde dersimizi işleyecektik. Şimdi müsaadenizle İngilizceye geçiyorum arkadaşlar. Dersi İngilizce anlatmamız gerekiyor. Okay my friends. 8086 architecture microprocessor lessons lab lesson. We are going to go over in English after this lesson because our lesson is in English, as you know. We have help section. I have already covered this tutorial previous week. We have help section. In the help section, we will go over every instruction set of 8086 from now on till this lesson ends. Today's topics are move instruction, add and subtract instructions. These instructions are the main, the most used instruction in our lab session. That's why be careful about these instructions. I'm going to start talk about directly not instructions, but some. Let me write something. Okay. Remember, when I emulate example code, we have this screen. This screen has left part is memory. This is the memory from beginning to end. All of the memory is here. Sorry for the mail. We have segments. The important part of these lessons is understanding the segments. For example, we have code segment, stack segment, data segment and exa segment. These segments are actually, let me say, pointers. They are pointing at some memory location at the memory. For example, let's go over and look at the code segment instruction pointer. There are twins, let me say twins. Code segment and instruction pointer. Let me zoom out a little. This is a twin. Data segment. Let me go over from here. Stack segment and stack pointer is twins. Data segment source index is twins. Exa segment destination index is twins. You have to memorize these twins. We are not going to use code segment instruction pointer because code segment just show that our compiled and running code is stored at var location. For example, let's go over and look at the 100 and 00. When you go to code segment 100 and 00, this is the first code, first instruction. Move AX to move 73 to AX code. This is stored in the 1000 place. This address is the combination of this code segment and instruction pointer. Instruction pointer states the next instruction where it's going to be run. For example, there is no second instruction. I'm going to update this code with, for example, add something like this. There's no comma in here. And I emulate this. Look at the instruction pointer. Instruction pointer is increased. Updated values will be colored as blue. And instruction pointer is 3. Get this twin, code segment and instruction pointer in here. And look at the 3. This is the next instruction we are going to run, which is add AX to AX. As you can see, instruction pointer pointing the next instruction that is going to be instructed. This is a bit complex for you now, but you just know that code segment and instruction pointer is a twin. Okay, let's get rid of them. Stack segment and stack pointer. This will be the 12th or 11th week of the topic. We are not going to use stack segment and stack pointer until that time. So just know that this is another twin. If you open the stack, there's a stack button at the end of this emulator. If you open the stack, the first line, the head of stack, is 100 and FFFE. When you go over and look at the register, stack segment and stack pointer, 100 and FFFE, stating the head of the stack. These are combination twins. I'm calling this twin. This is actually not twin. I couldn't remember the name of it. Anyway, twins. Just know that. Stack segment, stack pointer is another twin. For example, if you increase stack, the head will be decreased. We are going to cover that topic later. Actually, let's go over and look at the stack part. Push and pop. Lab 10 will be about stacks. Yes, it will be very far. Okay, that's why stack segment and stack pointer will be covered in the next weeks. Data segment and source index. This is the most used segment we are going to use in our lab session. Exa segment is also we are also going to use, but not that much because data segment is enough to use. If data segment is not enough, we are going to use exa segment or move operation. How can I say? There are other move operations like this moves operation in the next weeks. These operations we are going to use exa segment, but don't be confused about these segments. I'm going to erase the exa segment now. Now we have data segment and source index. I want you to forget about the source index part. Just know that we are working on data segment. Okay. What is data segment? Let's go over and look at the data segment. Data segment is 100. Default value of segments are, as you can see, code segment, data segment, exa segment, stack segment. All of them are showing the same place in the memory, except the stack pointer. Never mind. Stacks are showing the same place in the default empty. When we open a new code, it asks us what are you going to use this code, com template, exa template, binary, etc. But we have said that we are going to use empty workspace. Empty workspace is default values of segments. So default values will be 100, 100, 100. Okay. And there is also another topic, physical address of these twins. For example, 100 and these are all hexadecimal. You don't have to write H in here, it's H, but let's write it this way. This is data segment part. This is segment part. We don't know it's data segment or the exa segment. This is segment part, and this is the address part. We are going to calculate the physical address from this line, this statement. Actually, the calculation is very simple. You get the segment part, add this, but before adding this two part, you have to put a 0 at the end of a segment. This is the important part. Our segment is 100. You have to put a 0 at the end of segment, which is 1000. Right part is 1000. When we add this together, we are going to find the physical address, which is 2000H. By the way, these are H, hexadecimal, as you know. Let's remember, when I emulate the screen, we have here, let me zoom in here. In here we have, how can I say, identify or something. When I write the example address we have written in text editor, 100 and 1000. Let me write it in here. This is all hexadecimal, remember? And I enter. Did you get that? It go over the 2000H. For example, if I go over to 2000, who are going to say the place it will go? Is there any one who is listening me carefully? Is there an answer? What will be the place? Yes, thanks so much. It will go over to 3000. By using this part, we are going to debug our code. For example, I'm going to put some value at some place. For example, the way this is correct usage is this way. I'm going to explain this. You have to put hash in here. I'm going to use 17 hash and add, I don't know, something simple. The first line stating that we are going to put 73 hash into 1000 hash address. But if you didn't state data segment, it will put data segment automatically. But I state that we are going to use data segment address combination. So it will going to put some value in 2000 address. What is the value? It will be 73. I run the code and it's go over, and I'm going to go and look at that value. Oops, it didn't go over. Yep, now it's go over. As you can see, we put 73 hash H into 2000 memory location. This is the physical location of an physical address of a memory. Calculation of physical address of a memory. In Theo lesson, you will calculate the physical address of these combinations. It's important, but that's it. It's that easy. For example, let's change the data segment and calculate again. I'm going to change the data segment with value beforehand. Let's say the AX is 200. I'm going to change data segment with 200 and same code. The previous same code. I'm going to put 73 hash into this. I'm going over to 5 directly. Run this code and the 5 will be run. When I go over and look at the 1000, there's nothing. Because we have changed the data segment. Data segment is now 200, as you can see in here. We have to change the previous part, segment part, into 200. When I enter, as you can see, 3000 is now 73. Go over and look at the example in here. Data segment is 200. That's why this will be 200. Then the physical address will be 300. Let me use like this. Did you get the idea? You have to use combinations, these twins, data segment and some address. If you are not going to show or state this part, this is also correct usage. Our emulator correct this incorrect code into correct version. Let me show you. For example, this is our written code, but the machine part, the computer understand is the actual code is here. It put the data segment at the beginning of the part. It corrects it. For example, I run this code and go over and look at the 1000. It's 2000 is empty because data segment is changed. 3000 is updated. So showing data segment in front of this twin address combination is unnecessary if you are working with data segment. But sometimes we are going to use hexa segment. And if you use this combination, for example, I run this code and go over and look at the 1000 now. Physical location, this is segment. It's not saying this is data segment, this is hexa segment. This is just a segment. So if you state something beforehand, it becomes that. So this is now hexa segment showing here and updated. But data segment is also updated. If you go over and look at the 200 parts, it's not updated because this command, this instruction updates the 3000 physical address. Okay, so this part is important. Let me show this here. This part is important. We debug our code by just going and looking at the physical address directly. Okay, there's no other debug version. We go instruction by instruction and looking at the memory directly and viewing the changes in the memory. Okay, now I'm closing this emulator, closing this one and going over to Close. Just open the lab. Okay. The move command. The move command is the most important command because we move values to one place to another, one register to memory, memory to register, memory to memory. There's no memory to memory move, remember. That's why we are going to go over and look at the move command. Let me. Okay, move command. I'm going to write every combination in here to here. For example, the first combination, register to memory. Move, by the way, it was wrong usage. The first parameter is register memory, but this is memory to register move command because it copy operand 2 to operand 1. Be careful. Second one copies into first one. Move 1000H to AX. This is, remember, semicolon is command in our emulator. This is rect to memory. The second one, memory to rec. This is opposite one, as you can understand from the above. Which is memory to, rec to memory. Statements are important. This is register to register. VX is a register. AX is a register. This is register to register. Memory to immediate. Immediate is actually constant value. So memory to immediate means we need a memory and we need an immediate value. I keep writing 73, but it can be anything. For example, AAH or just A, 0A. For example, 1. This is decimal, hexadecimal, all same. By the way, I'm going to mention the numbers when it comes in here. If you are going to write a number in decimal, you don't have to put anything after that number, but you can put D, which means decimal, which means it's 10 base system. If you are going to use hexadecimal system, you have to put H at the end of this system. If you are going to use binary version, for example, you can use directly binary, you have to put B at the end of this number. This is a binary number. Emulator will convert this number into hexadecimal and work with it. B, D, H. These are different types of number, but if you didn't put anything, for example, like this, it will become decimal. I'm going to put 4 hexadecimal in here. This is immediate to memory. Immediate to memory. And the next one is register, immediate to register. We keep using AX, but there are other registers, for example, DX. DX is also our register. And we need an immediate value, for example, this time 13 decimal. 13 decimal. Muharrem hocam mesajınızı aldım. Tamam hocam, bitirebiliriz. 13 decimal. The other parts, the segment register memory, this is the important part of this move command. For example, segment register. What are the segment? Data segment, exe segment, code segment. We are going to go over data segment. I'm going to write data segment memory. 1000H move 1000H to data segment. S register means segment register. These are segment registers. Another one is register to segment register. Let's say DS to AX. This is segment register to register. Move data segment, for example, register. These are all the combinations in here. I'm planning to write all this in comment, but I think it will be waste of time. Let me show you this way so that you can understand. The 5 different versions of move parameters are above. The 4 segment register parameters are below. These are this second column. So this is move command. If you are going to put a value something, put some value into some register, segment register, or memory, we are going to use move. I'm going to emulate and see this code. For example, 1000H doesn't have a value, it has 0. It means put that 0 into AX. It's going to put that 0 into AX, etc., etc. So this is move. I'm going over and to next code. Addition, add command. What we are going to do, we are going to open help section, instruction set, and add command. Add command is here. Parameters, combinations of parameters are here. What is it doing? It's just adding. Adding the operand 1 and operand 2 into operand 1. The important part is this. Let me go over and write add. For example, AX to memory. This is the first line, memory to register, which means there is some value in 1000H. Let's say 1000H has value into 1000H. Let's say 1000H has 1. This means AX equal to AX plus 1. Because 1000H address of 1000H is 1. Let me correct myself. 1000H address consists of one value. Address is 1000H. So address of 1000H consists of 1. That's why the resolution is this. The left part, operand 1, as you can see from here, operand 1 plus operand 2 is going to move to operand 1. For example, copy this code. Oops. 3 times and see what it is doing. Move 1000H1. I'm going to go over and look at the 1000H. It says 1 value in it. I'm going to add AX. AX is the combinations of these two. AX is here, A high and A low. High and low part of AX. AX is here. Run this code. As you can see, AX is now 1. Now the second part. we are going to add ax plus 1 again. Now ax is 2, ax is 3 times. Run this code. Addition comment with the first parameter combination. Second parameter combination, memory to register, the opposite version of this. I'm not going to mention that. Register to register. This will be mostly used one. For example, bx to ax. Not move, but add. Ex to ax, yep. Let's run this code. We have already covered the first 4 line. Ax is now 3, and this line will add the bx value. Bx value is 0. 0 plus 3 into bx. As you can see, bx become 3. Okay, this is register to register. This can be also same register, adding itself into it. For example, let's run this into ax. Result will be 6. I'm going step backward for 1. Ax is 3, 3 plus 3 is 6. Put this 6 value into ax again, and ax is now 6. These are hexadecimal, but we are under 16, and that's why it looks like decimal. That's the point. Okay, this is add command. I'm going over to next command, subtract command. Çıkarma, subtract command. What are we going to do? We are going to open help section, instruction set, and subtract command. Subtract command parameters are same with addition command, add command. Algorithm is operand 1 minus operand 2 is moves into operand 1. The important part is addition is not depend on the, how can I say, order of the operands, but subtract order is important because operand 1 minus operand 2, the correct usage. I'm going to update these all into something. Let's say WinHash has 6 value. I'm going to use subtract command with bx first. When I emulate this, we put 6 at 1000, 2000 physical address, 1000 address location. 6, and I subtract ax minus 6. Oh, it's minus. Let's run this, and you will see the negative values. For example, ax. As you can see, ax is now FFFA. I'm going to go over and open the converter. AX, which is 16-bit register. We are going to cover that later. AX is 16-bit register. What is the value? FFFA, which you can see is minus 6. Run again, a single line. Let me show it. 3 times have been run, and I'm going to open converter again. FFEE, which is minus 86. Okay. So this way we cover the minus part also. I'm going to update this. Something like this, and move AX. Let's say AX has 1 in it. Remove this part. Run. Put 1 in AX. Move 1000H. Move 6 in 1000H. Let's go over and look at 1000H. It has 6. And now subtract 1000H value, which is 6, minus AX, which is 1, 6 minus 1, 5. The result will be stored in 1000H. So when I run this code and go over and look at the 1000H, it becomes 5. Remember, it was 6, it becomes 5. When I run this code again, the next line, same line, it becomes 4. As you can see, with a single line of instruction, I'm updating the memory location directly. Okay, subtract Bx minus Ax into Bx, which will be minus 1. As you can see, 0 minus 1 become minus 1. Minus 1 is FFFF. So Bx become FFFFF. FFFF. This is minus 1. Okay. The subtract command is also covered. Now the PDF continues with examples. If the lessons were not online and we were in university, I want you to write these examples and solve these examples in your computers. But now we are in online and we are going to cover this code I'm going to cover this code by myself. I'm going to write this code by myself. I want you to try these examples by yourself after these lessons. These are very simple examples. I'm going to write this code directly. Let me move it into right. Okay. This is not good. Okay, but saying write an Intel 8086 assembly code that will write 30H value to 1000H and 2000H memory addresses. By the way, this is wrong usage. I need to update this. It should be 8086, not x86. It's saying that put means move, write, whatever you use that for, into 1000H. I'm going to use 1000H. What is the value? Value will be 34H and also 2000H. Move 2000H, also put 30H. That's all. The simplest form is this. When I emulate this code, it will put 34 at 2000 and 34 at 3000. But the correct usage is you should update the data segment at the beginning of your code because the default values may vary. For example, default value is 100, but you have to update data segment. Data segment cannot directly update, by the way. That's why we are going to put immediate value into AX and put that AX value into data segment. Now data segment is 100 and implicitly stating segments before addresses will be the correct usage of our code. This is exactly the same code, but more correct version. Data segment is already 100, so this didn't change anything. We update 1000 and 3000. Go over and look at 1034 and 2034. As you can see, same code. This is the answer of first question. By the way, I'm going to publish the answers on the third column of codes column. You don't have to screenshot or go over and look at the answers in the video. I will publish the results in codes column. Okay, now second question. Second question is write an assembly code that will swap the values of CL and DL. I just want you to remember We have AX, BX, CX, DX register, which are 16 bits registers, but we can split this register as high and low part. For example, this is AH, higher boundaries of AX. And we can use this two parts differently. For example, I can put 11 hash into high part and 73 into low part. When I emulate this and run this code, high part will be 11, low part will be 73. If you are going to work with 8 bits, the high and low parts will be 8 bits. The AX, the combinations of high and low part will be 16 bits. These are important things. 16 bits also called word, kelime, word. 8-bit also called, as you know, byte. Byte and word. These words will come across on the next weeks. So, code saying that swap the values with CL and DL. Let's move some value into CL and DL. Let's say CL and DL has these values, and I'm going to swap this codes. For example, in C, what are you going to do? You are going to define a temporary variable, put the CL into temporary variable, and update the CL with DL, put that temporary variable into DL. This will be the thing. But in assembly, we doesn't have variables yet. That's why I'm going to use another register. Let's say AL. I'm going to use AL as a temporary variable and put CL into init. Now AL becomes CL, which is 11. Let me write this way. Temporary things. Now put DL into CL, the swap operation. The destination will be CL. The source will be DL. This will update CL as 73. And now I'm going to update DL with AL. This will update DL with AL, which is also 11. And I run this code, the first two lines, 11 and 73. I want these to swap. I'm going to use AL as a temporary variable, put 11 into AL, update CL, and then update DL with AL. As you can see, CL and DL swapped. That's all. The third value, the third question. This will be the last question, and we are going to end this record in there. Actually, end this record in here. Muharrem hocam, orada mısınız?
Evet. Evet hocam buradayım.
Hocam kaydı durdurabilirsiniz siz. Ben küçük bir ara vereyim. Kalmak isteyenlere devam edeceğim. Sonrasında ek ders gibi olacak. Kaydı durduralım hocam.
Tamam. Katılan arkadaşlar için teşekkür ederim. Abbas hocam size de teşekkür ederim.
Ben teşekkür ederim hocam.
Hoşçakalın.